September 1985, Persian Gulf. An Iranian F-14A Tomcat climbs through 30,000 feet. Lieutenant Commander Jalil Zandi settles into his seat while his radar intercept officer activates the AWG-9 radar system. The radar sweeps the sky ahead, and within seconds, multiple contacts appear on the display. Iraqi aircraft inbound from the northwest. Range: 120 nautical miles. The formation consists of 4 aircraft, likely MiG-23 floggers, proceeding directly toward Iranian oil facilities in the Karg Island complex. Zandi's RIO calls out the contacts. The AWG-9 radar tracks each aircraft individually, displaying precise range, altitude, heading, and speed data. At 90 miles, the decision comes. Phoenix launch authorization confirmed. The F-14's weapons bay doors open. A single AIM-54 Phoenix missile drops free. Its solid rocket motor ignites, and the weapon accelerates toward Mach 5. The Iraqi pilots maintain their course, unaware that American technology is already tracking them from beyond the horizon. At 70 miles, the Phoenix missile's active radar seeker acquires its target. The Iraqi formation breaks apart as radar warning receivers suddenly activate, but evasive action comes too late. One Iraqi aircraft ceases to exist as a radar contact. The formation scatters, diving for lower altitude, but they're still 60 miles from visual range with the F-14. They never saw their opponent. They never had a chance to engage. Soviet military observers attached to Iraqi air defense units watch their radar screens in disbelief. This is not the air war Soviet doctrine prepared anyone to fight. For the Soviet Union, September 1985 marked more than another engagement in a distant regional conflict. It revealed that American naval aviation had achieved capability gaps Soviet designers thought impossible. The Soviets possessed capable interceptors, experienced pilots, and sophisticated ground control networks. But American technology had leapt an entire generation ahead. The F-14 Tomcat and its Phoenix missile system represented warfare conducted beyond visual range, beyond Soviet doctrine, and beyond the technical capacity of Soviet industry to replicate. Soviet interceptor doctrine in 1985 held firmly to principles developed in the 1950s and refined through the 1960s. Visual identification remained mandatory before engagement. Soviet pilots trained extensively in close-range combat, emphasizing gun employment and short-range missile tactics. The standard Soviet intercept profile called for ground control intercept operators to guide fighters to within 10 miles of targets, where pilots would visually acquire and engage using R-60 heat-seeking missiles or cannon fire. This doctrine reflected both technological limitations and tactical philosophy developed during an era when beyond visual range combat seemed impossible. The MiG-23 flogger, introduced in 1970, embodied Soviet interceptor philosophy. Its Sapphire-23 radar could detect fighter-sized targets at approximately 30 miles under ideal conditions, but target tracking required manual pilot input. The system struggled to distinguish low-flying aircraft from ground clutter. Soviet pilots joked that the Sapphire-23 could detect mountains quite effectively, but often lost actual aircraft in the process. The MiG-25 Foxbat, despite its Mach 3 speed capability, carried Smersh-A radar optimized for large bomber targets, not fighter-sized aircraft. Both aircraft carried R-40 missiles with maximum effective ranges around 25 miles, but only under perfect conditions, with cooperative targets flying straight and level. Soviet training philosophy reinforced these limitations. Fighter pilots received approximately 120 flight hours annually, with emphasis on intercepting large bomber formations under ground control guidance. Soviet doctrine assumed that American carrier battle groups would employ F-4 Phantoms and A-6 Intruders in massed attacks, where Soviet fighters would engage in traditional dogfighting after ground controllers positioned them properly. The concept of autonomous fighter operations, where individual aircraft detected, tracked, and engaged targets without ground control support, remained foreign to Soviet tactical thinking. Soviet military leadership understood American technological advances existed, but assessments consistently concluded that complex American systems would prove too unreliable for actual combat employment. Official Soviet technical publications from the early 1980s described the F-14 and Phoenix as theoretically capable, but practically limited by excessive complexity and cost. Soviet analysts noted that the F-14 required extensive maintenance, that the Phoenix missile cost nearly $1 million per unit, and that such sophisticated systems would inevitably fail under actual combat stress. These assessments proved catastrophically wrong. The F-14 Tomcat emerged from a specific tactical problem that Soviet designers never adequately addressed. In the late 1960s, American naval intelligence identified a critical vulnerability. Soviet naval aviation had developed long-range cruise missiles carried by Tu-22M backfire strike aircraft. Soviet doctrine called for massed backfire attacks against American carrier battle groups, with dozens of aircraft launching hundreds of cruise missiles from ranges exceeding 200 miles. American carriers needed a defense system capable of engaging multiple bomber formations simultaneously before missile launch, which meant intercepting aircraft at ranges exceeding 100 miles. Grumman Aircraft Engineering Corporation responded with a revolutionary approach. The F-14 would carry the most sophisticated radar system ever installed in a fighter aircraft. Hughes Aircraft Company developed the AWG-9 system, which represented a complete departure from previous fighter radar design. The AWG-9 employed pulse Doppler technology that allowed it to detect fighter-sized targets at ranges exceeding 100 miles, while simultaneously tracking up to 24 targets. The system could maintain track files on all 24 targets, while engaging 6 simultaneously with Phoenix missiles. No other fighter radar in the world approached this capability in 1970. The AWG-9 radar incorporated processing power that exceeded entire Soviet air defense networks. The system employed multiple operating modes, automatically selecting optimal frequencies and pulse repetition rates based on target characteristics and environmental conditions. When engaging multiple targets, the AWG-9 could assign individual Phoenix missiles to separate aircraft, with each missile receiving updated target information until its own active radar seeker acquired the target. Soviet fighter radars in 1970 could barely track single targets reliably. The concept of simultaneously engaging 6 different aircraft exceeded Soviet technical capabilities by a decade. Hughes Aircraft paired the AWG-9 with the AIM-54 Phoenix missile, which represented equally revolutionary technology. The Phoenix weighed 1,000 pounds, measured 13 feet in length, and carried a 132-pound warhead. Its solid rocket motor propelled the weapon to speeds exceeding Mach 5, giving it kinetic energy that supplemented the explosive warhead. But the Phoenix's true revolution lay in its guidance system. The missile employed semi-active radar homing during its initial flight phase, receiving targeting updates from the F-14's AWG-9. At predetermined range, typically around 20 miles from the target, the Phoenix activated its own miniaturized active radar seeker, which acquired and tracked the target independently. The launching aircraft could immediately turn away while the Phoenix continued to its target autonomously. This terminal active radar guidance distinguished the Phoenix from all Soviet air-to-air missiles. Soviet systems employed semi-active radar homing throughout their entire flight, requiring the launching aircraft to maintain radar illumination until impact. Soviet fighters had to point their radar continuously at the target, making them vulnerable to counterattack and unable to engage multiple targets effectively. The Phoenix's active terminal guidance allowed F-14 crews to employ ripple-fire tactics, launching multiple missiles at different targets in rapid succession, then maneuvering defensively while the weapons prosecuted their attacks independently. The F-14 airframe matched its weapons system sophistication. Grumman designed the aircraft around variable geometry wings that optimized performance across the entire flight envelope. At high speeds, the wings swept to 68 degrees, reducing drag and maximizing acceleration. At low speeds, the wings extended to 20 degrees, providing the lift necessary for carrier operations. 2 Pratt & Whitney TF-30 turbofan engines provided sufficient thrust for sustained supersonic flight while maintaining reasonable fuel consumption during subsonic patrol operations. The F-14 could launch from carrier decks, climb to combat altitude, patrol for hours on station, engage multiple targets at extended range, and return to the carrier, all while carrying 6 Phoenix missiles, 2 Sparrow missiles, 2 Sidewinder missiles, and an M61 Vulcan cannon. The complete F-14 system cost $38 million per aircraft in 1973, approximately twice the cost of an F-4 Phantom. Soviet analysts noted these costs and concluded that the F-14 represented an unsustainable program. They were correct that the US Navy ultimately purchased fewer F-14s than originally planned due to cost considerations, but Soviet assessments missed the critical point. The United States possessed both the technological capability and industrial capacity to build such sophisticated systems, while the Soviet Union could do neither. Soviet industry in the 1970s struggled to manufacture the integrated circuits necessary for systems like the AWG-9. While American manufacturers produced millions of reliable integrated circuits annually, Soviet electronics plants operated with yields below 50% and reliability far worse. The miniaturized components in the Phoenix's active radar seeker exceeded Soviet manufacturing capabilities entirely. Soviet attempts to develop similar weapons consistently failed, not because Soviet engineers lacked understanding, but because Soviet industry lacked the manufacturing precision, quality control, and component reliability necessary to make such systems function. The F-14 entered operational service with the US Navy in October 1974 aboard USS Enterprise. By 1976, American carrier battle groups routinely demonstrated Phoenix capability in exercises, successfully engaging target drones at ranges exceeding 100 miles. Soviet intelligence gathered extensive information about F-14 operations, and Soviet military leadership recognized the threat. But recognition and response capability represented two different things. Soviet attempts to develop equivalent systems consistently failed to achieve operational status. The Islamic Revolution in Iran in 1979 provided the Soviet Union with an unexpected opportunity. Iran had purchased 79 F-14A Tomcats between 1974 and 1976 as part of a broader military modernization program. When the revolution toppled the Shah's government, Iranian-American military cooperation ended abruptly. The United States implemented strict embargoes, preventing any spare parts or technical support from reaching Iran. Soviet military intelligence assumed that Iranian F-14s would become inoperable within months as maintenance issues accumulated and spare parts inventories depleted. Iranian Air Force engineers proved remarkably resourceful. They established maintenance programs that kept significant portions of the F-14 fleet operational, despite zero official support from the United States. When Iraq invaded Iran in September 1980, Iranian F-14 squadrons immediately demonstrated their continued effectiveness. Iraqi Air Force pilots, flying Soviet-supplied aircraft and trained in Soviet tactical doctrine, encountered an opponent they were completely unprepared to face. The Iran-Iraq War provided the first large-scale combat employment of F-14 Tomcat systems. Iranian F-14 pilots, many trained in the United States before the revolution, understood the aircraft's capabilities thoroughly. They employed tactics designed around the AWG-9 and Phoenix combination, patrolling at high altitude and engaging Iraqi formations from ranges where Iraqi aircraft couldn't even detect the F-14's presence. Soviet military observers attached to Iraqi forces witnessed these engagements directly and reported extensively to Moscow about what they observed. Lieutenant Commander Jalil Zandi became the most successful F-14 pilot during the conflict, credited with successful engagements against 11 Iraqi aircraft. His typical engagement profile exemplified F-14 tactical employment. Iranian ground control would vector F-14 pairs toward Iraqi formations detected by ground radar. At ranges exceeding 100 miles, the F-14's AWG-9 would acquire multiple targets. The crew would analyze the tactical situation, identify priority targets, and begin engagement procedures at ranges between 80 and 100 miles. Phoenix launches typically occurred at 70 to 90 miles, well beyond the range where Iraqi aircraft could detect the F-14 or employ their own weapons. Iraqi pilots described these engagements in terms of complete helplessness. Their radar warning receivers would activate suddenly, indicating that radar had locked onto their aircraft. Before they could react, missiles would appear in visual range, traveling at speeds that made evasion impossible. Iraqi formation discipline collapsed as pilots scattered in all directions, attempting to evade threats they couldn't see and weapons they couldn't outmaneuver. By the time Iraqi pilots achieved visual range with the attacking F-14, the engagement had already concluded. The F-14 would either have expended its weapons or would be withdrawing at high speed, using its superior performance to disengage before Iraqi aircraft could position for counterattack. Soviet military observers documented these engagements carefully. Their reports back to Moscow contained detailed accounts of how Iranian F-14s consistently achieved successful engagements against Iraqi formations without ever entering visual range. The reports described Iraqi pilots' complete inability to counter F-14 tactics, noting that standard Soviet interceptor doctrine provided no effective response to beyond visual range engagement. Soviet observers recognized that if Iranian crews, operating without spare parts or technical support, and often flying aircraft with degraded systems, could achieve such dominance, then US Navy F-14 squadrons with full logistical support represented an insurmountable challenge. The Phoenix missile's performance particularly impressed Soviet observers. Multiple engagements demonstrated the weapon's ability to successfully engage maneuvering targets at ranges exceeding 60 miles. The missile's high speed and large warhead meant that even near misses often resulted in sufficient damage to neutralize aircraft. Iraqi aircraft that survived initial Phoenix engagements often sustained damage that forced them to abort missions and return to base immediately. The Phoenix's terminal active radar guidance meant that Iranian F-14 crews could launch against multiple targets, then maneuver defensively while the missiles independently prosecuted their attacks. Iranian F-14 operations also demonstrated another critical capability gap. Soviet fighter doctrine relied heavily on ground control intercept systems, where ground-based radar controllers guided fighters to intercept positions, then handed off targets for final engagement. This system worked adequately against predictable bomber formations but struggled against fast-moving fighter-sized targets employing tactical maneuvers. The F-14's AWG-9 radar gave aircrews complete tactical autonomy. F-14 crews could detect, track, and engage multiple targets without any ground control support, making tactical decisions based on real-time information available only to them in the aircraft. This autonomy reflected a fundamental difference in American and Soviet tactical philosophy. American doctrine emphasized decentralized decision-making, where individual pilots and crews made engagement decisions based on their assessment of the tactical situation. Soviet doctrine emphasized centralized control, where commanders on the ground made tactical decisions and fighter pilots executed those decisions. The F-14's sophisticated systems enabled American tactical philosophy to function at ranges and engagement speeds, where Soviet centralized control simply could not react quickly enough. Soviet attempts to develop equivalent capability consistently failed throughout the 1980s. The MiG-31 Foxhound, introduced in 1981, represented the Soviet Union's most sophisticated interceptor. Its Zaslon radar could track multiple targets at extended range, and its R-33 missile had theoretical range approaching 60 miles. But the Zaslon radar struggled with reliability, often requiring extensive maintenance after each flight. The R-33 missile remained semi-active throughout its flight, requiring the launching MiG-31 to maintain radar illumination until impact. Soviet crews could engage one target at a time, while F-14 crews could engage 6. The technological gap persisted. Soviet industrial limitations prevented development of systems comparable to American integrated circuits. Soviet manufacturing processes struggled to produce components with the miniaturization, reliability, and performance necessary for sophisticated avionics. When Soviet engineers attempted to reverse engineer captured or purchased American electronics, they found that Soviet factories simply couldn't replicate the manufacturing precision required. Quality control in Soviet defense plants while better than in civilian industry, still fell far short of American standards. Components that American manufacturers produced with 95% reliability emerged from Soviet factories with 50% reliability at best. This industrial gap reflected broader systemic differences between American and Soviet approaches to technology. American defense contractors competed for business, driving continuous innovation and efficiency improvements. Soviet design bureaus operated as state monopolies, insulated from competitive pressure. American engineers could access global markets for components, incorporating the most advanced technology regardless of origin. Soviet engineers relied entirely on domestic production, limited by Soviet industrial capabilities. These structural differences ensured that the technological gap would persist regardless of Soviet efforts to close it. Soviet training and doctrine also struggled to adapt to beyond visual range combat. Soviet pilots received extensive training in close-range maneuvering combat, learning to exploit their aircraft's capabilities in traditional dogfighting. This training became largely irrelevant when facing opponents who engaged from ranges where visual contact never occurred. Soviet tactical manuals from the early 1980s contain virtually no discussion of defending against beyond visual range attacks, because Soviet doctrine assumed such engagements remained impractical for actual combat. Iranian F-14 operations proved this assumption catastrophically wrong. The psychological impact on Soviet pilots proved significant. Soviet fighter pilots took pride in their training and capabilities, confident that their skills and their aircraft could compete effectively against Western opponents. But beyond visual range combat eliminated the relevance of pilot skill in traditional maneuvering. When the enemy engaged from 100 miles away, pilot reflexes and aircraft maneuverability meant nothing. The entire foundation of Soviet fighter pilot training became obsolete in an instant. Soviet pilots recognized this reality and understood that their chances of survival against F-14s carrying Phoenix missiles approached zero. Soviet naval aviation underwent extensive doctrinal revision in response to Iranian F-14 operations. The previous assumption that Soviet bomber formations could approach American carrier battle groups to within 200 miles for cruise missile launch proved untenable. American F-14s would engage Soviet bombers at ranges exceeding 100 miles, well before the bombers could launch their weapons. Soviet planners recognized that massed bomber attacks against American carriers would result in catastrophic losses without achieving their objectives. This forced fundamental changes in Soviet maritime strike doctrine, with greater emphasis on submarine-launched cruise missiles and long-range land-based missiles that could engage carriers from ranges exceeding 500 miles. The strategic implications extended beyond naval aviation. If American aircraft could engage Soviet aircraft from beyond visual range, then air superiority over any battlefield became questionable. Soviet ground forces depended on air superiority, or at least air parity, to conduct operations according to Soviet doctrine. If American aircraft could achieve air superiority by engaging Soviet fighters before they reached the battlefield, then the entire Soviet operational approach faced fundamental challenges. Soviet military planners spent the late 1980s attempting to develop responses to American technological advantages. But the collapse of the Soviet Union in 1991 ended these efforts before effective solutions emerged. The F-14 Tomcat remained in US Navy service for 33 years, finally retiring in 2006 as the F/A-18E F Super Hornet replaced it in carrier air wings. During its service life, the F-14 never engaged in beyond visual range combat while serving with the US Navy, though F-14s successfully engaged multiple Libyan aircraft in incidents over the Mediterranean Sea in 1981 and 1989. The absence of F-14 combat employment by the US Navy reflected deterrent success rather than capability limitations. Soviet and later Russian military planners understood that American carrier-based aviation possessed capabilities they could not match, and they planned accordingly. Iranian F-14s, remarkably, remain operational in 2025, 49 years after their initial delivery. Iranian engineers developed indigenous maintenance capabilities and even manufactured certain spare parts domestically. While Iranian F-14s operate with degraded capability compared to their original specifications, they continue to provide Iran with air defense capability that regional opponents cannot match. The aircraft that Soviet analysts predicted would become inoperable within months of the Islamic Revolution continues flying decades later, a testament to the fundamental soundness of the F-14's design. Modern air combat has fully embraced the beyond visual range engagement philosophy that the F-14 and Phoenix pioneered. Current American fighters like the F-22 Raptor and F-35 Lightning II incorporate far more sophisticated radar systems and weapons than the F-14 carried, but they operate according to tactical concepts that the F-14 established. Russian fighters like the Su-35 and Su-57 similarly emphasize beyond visual range capability, incorporating active radar-guided missiles and sophisticated radar systems. These developments validate the F-14's revolutionary approach, while highlighting how far Soviet doctrine lagged behind American capabilities in the 1980s. The F-14 and Phoenix represented more than technological achievement. They embodied a complete tactical philosophy that Soviet doctrine never adequately addressed. American naval aviation recognized that air superiority in the modern era required the ability to engage multiple targets simultaneously at extended range, eliminating enemy formations before they could employ their own weapons. Soviet doctrine, constrained by technological limitations and rigid centralized command structures, never developed effective counters to this approach. When Iranian F-14 crews demonstrated Phoenix effectiveness during the Iran-Iraq War, they revealed capability gaps that Soviet military leadership had suspected, but hoped remained theoretical. The story of the F-14 Tomcat and its Phoenix missile system illustrates how technological innovation creates strategic advantages that persist for decades. Soviet designers understood the concepts behind beyond visual range combat, but Soviet industry could not manufacture the components necessary to make those concepts operational. Soviet doctrine emphasized centralized control and visual range engagement, but these approaches became obsolete when facing autonomous systems that engaged from beyond the horizon. Soviet training produced skilled pilots expert in maneuvering combat, but those skills became irrelevant when the enemy never approached visual range. Soviets designed fighters for the war they fought in 1960, where close-range maneuvering and pilot skill determined outcomes. America built fighters for the war they would fight in 1990 and beyond, where sophisticated sensors, long-range weapons, and autonomous systems decided battles before aircraft ever came within visual range of each other. The F-14 Tomcat and its Phoenix missile system represented this future, and Soviet military observers who watched Iranian F-14 operations in 1985 recognized immediately that their nation's fighter doctrine had become obsolete overnight. That recognition came too late to change the outcome. American technological superiority in beyond visual range combat persists to this day, built on foundations that Grumman and Hughes established when they developed the F-14 Tomcat more than 50 years ago.